my name is Nicholas. I'm a mechanical engineer and robotics software engineer for underwater vehicles, meaning I develop new computer programs that allow these robots to communicate without a human operator. This is an example of the type of vehicles I work with. These are underwater robots that can be programmed to explore the ocean floor. Depending on my approach when developing a new program, I will often repurpose existing code that others wrote for a different application and build my code from that foundation. When I do this, I try to credit the original creator whenever possible. I have found that a majority of people in computer science share this approach as it encourages us to become better team members and programmers through collaboration and more rapid development. Often, we will add comments to our code to help us communicate the function of a part of the program to others and our future selves. These are a type of inline annotation that the computer ignores when it actually runs the program. I find my own comments to be some of the most useful tools when revisiting my old code. They allow me to reconstruct what the purpose of specific parts of the code actually were. When approaching a new program, I usually look at the comments first. But sometimes I also need to experiment with the code to test if it actually does what I think it should do. This can take a while, since there's a lot of experimentation involved with developing my own understanding of the smaller parts that can make up the whole program. Sometimes I try removing a line or block of code, and sometimes I try copying and pasting the code into new locations. Testing how the program operates with small changes to it helps me better understand what particular sections of code actually do. There are often many different ways you can write and sequence the instructions or code that a computer will follow to produce a set of outputs from the same set of inputs. This is part of what makes programming feel so creative. There are many approaches myself and others use when we first start developing a new computer program. Sometimes most of our work is simply identifying the variables we will need to keep track of and an outline of the algorithms or mathematical operations the computer will need to do. Much of this can be done on paper or, most commonly, a whiteboard. Sometimes we develop flowcharts to indicate the steps the computer needs to take between each decision point in the program. This can also mostly be done on paper or a whiteboard. One common thing we identify in such outlines are conditionals. Conditionals are if-then statements and blocks of code that are used in most computer programming languages to indicate a decision point for the computer. These are points in the program where we need the computer to perform a comparison or calculation, and then use the result to determine whether or not to follow an additional set of instructions. Sometimes in these conditionals, the computer needs to be instructed to make more than one comparison before deciding if it should produce a desired output. I think of computer programming as another kind of engineering. Like other types of engineering, we analyze data from tests to determine similarities and differences among several design solutions to identify the characteristics of each that can be combined into a new solution. Some of the tests we do are in virtual environments on the computer, while others are on physical systems that we interact with in real-world settings. We seek and incorporate feedback from many different team members and users to refine a solution that meets the user's needs. This ultimately is the goal of every design project that I work on. I am provided a problem from my end users, and then I design something novel that addresses that specific problem, which is where the creativity and innovation come in.